Good, let's try another problem, right? In a nutshell, gang, we know what it takes. And so, here we go. Steve's crib sheet number 1. Ladies and gentlemen, that is what we're paid to do. Our job is to inculcate learning. Our job is to produce kids who are successful. It is not easy to do. It is not easy to do in this world where we are being told that it's not just about getting answers, but it is about problem solving. It is about reasoning. It is about constructing arguments. It is not easy to do that we have kids successful. We know that we cannot snap our fingers and have learning just automatically emanate throughout our classroom. Walk down the hall. You know when kids are sitting mindlessly doing worksheets or wasting their time, and you know when kids are actively engaged like this class just was. You show me a classroom where there is engagement, where there is participation, and I think that you all know that that's productive noise, and that is an environment where it is most likely that learning is going on, because learning is an active process. Learning is a socially mediated process. Very rarely do we learn by sitting at a computer screen. The computer screen is great for entertainment and for practice. It's not about teaching and learning in most cases, although every year we get slightly better software to do those kinds of things. You can't snap your finger and get kids to engage, and so the question is, what did I just do? What does Principles to Action say we all need to do? It's very simple. It says that it is most likely that kids are going to be engaged when I give them tasks that are interesting, tasks based on data, tasks based on the class system of how rich I am and how poor you are, right? I ask them questions. I engage them in the discourse because of my questions. I honor mistakes. I love mistakes. Mistakes are learning opportunities. Oh, it's so much fun to do what I do. So I do all this co-teaching, I do all this demonstration lessons and things like that, and we plan lessons and then I do it, and I forever end my lessons with, what did you learn today? And you know, you're not supposed to call on the kid that has autism, because no one ever calls on that kid. You don't call on the kids that are ELL kids. Not that you have many ELL kids here, but there are a couple, right? You've got kids that you don't call on those kids because they can't answer the question. And what do? I always call on those kids. And so, what'd you learn today? Great. What'd you learn today? Ian, what'd you learn today? The whole class goes, he called on Ian. You don't call on Ian. I go, I know, just relax. Ian's clearly on the spectrum. Right? Ian stands up and he says, I learned that I'm smarter now than I was before you started this class, Mr. Steve. I go, why is that? He says, because I made 3 mistakes, and mistakes grow your brain. I'm smarter. Oh, I know. The teachers in the back of the room almost fell out of their chair, right? It's the first time Ian talked in 3 months. It's just realized, right? And so I love mistakes. I love what they do. And I got productive struggle in those ways, and we're going to come back to productive struggle. And when it is supported by the only things that matter. How did you see it? How did you see it? How did you see it? How did you represent it? How did you represent it? When how did you do it? How did you do it? How did you do it? And what's a reasonable estimate? I have the essence of helping kids build mathematical understanding. Stop. I think that we tend to be too meek. We tend to be too sheep. My point is that far too rarely do we have the guidance to go do it. How many of you have a coach in your school who knows something about math? Look at that. That's just under half. That's exciting. So that's who can do it, hopefully. How many of you have a coach that is a literacy coach as opposed to a math coach? Yeah, there you go. How many have a math coach, a dedicated math coach in your school? A lot fewer hands. You know that that's the only person who can help. That's the only person who can do it. And so we've got to find a way to recognize that. Stop. Differentiation is one of those horrible terms like rigor that just gets bandied around and misused. I'm here to tell you that differentiation means nothing more and nothing less than you have 22 different brains in your classroom. Those kids are processing it in 8 different ways. They are visualizing it in 6 different ways. Your job is to recognize kids. If we only have one approach. And so look what we had with John's way, and with Janelle's way, and with Tanya's way, and with Melissa's way. All those different approaches, and then the kids, oh yeah, that's the way I did it. Who did it differently? Now, go and use that approach on another problem. And so when it's all guided by a clarity of our goals, we have. And so I give you a grip sheet, I give you a planning document, I remind you to reflect on your lessons that worked and say, yeah, it worked because, it worked because. It didn't work because. And so if all that makes sense, let's put all this together into a lesson that embodies all 8. Take a deep breath. So look at this is March 2017, right? NITO. This is a class. So here's what I've been doing more and more of. This is fun. Is sitting with all 5 second grade teachers for 3 hours. I've been working at Omaha. I go to Bryant High School and I work with all 6 Algebra 1 teachers for 3 hours. Hour 1, what's going on, what's working, what's not working, what has been problematic, who's teaching the lesson today. We spend 45 minutes planning a lesson. While they're talking, I'm putting a set of slides together. I then go teach the lesson. I can teach a lesson if in fact I've collaborated on the slides. I know mathematically where it is, right? So I teach this lesson. And then the most important thing of all, the professional development, the modeling that I want to ask coaches to adopt is then we have 1 hour driven by 3 questions. Sitting with you for 3 hours. And that last hour is what worked and why, with the emphasis on why. What would you do differently? What didn't work as well? If you're going to teach this lesson, how would you adjust it? And the last 20 minutes is the commitment time. Professional development that ends up in you making a commitment to do something differently. The last 20 minutes of the discussion is what 1 or 2 things would you do differently on the basis of the 3 hours we spent together. And so this is warts and all. I refuse to change these lessons because I don't want to show you perfection. I want to show you collaborative work. I want to show you the fact that we only had 45 minutes to do this. I want to show you that I'm now going to work with second graders. And so this is the result of 45 minutes with 6 teachers. Right? Use strategies to find the difference of 2-digit numbers, okay? Boys and girls, you need to be on the rug, right? You need to have your whiteboards and markers and bring the base 10 blocks, okay? Ready? Good. Boys and girls, what are we doing today? I'm sitting on the rug, okay? I sit right down with the kids and say to them, remind me what we're going to do today, okay? You guys are second graders, you can read. We're going to use strategies, good. And we say, all right. Turn to tell your partner what's a strategy. Well, why not? If we're going to use strategies, I'm going to kind of kid-friendly language. I want kids to use that stuff. And so again, we start off with a slide that captures the key aspects of the lesson, and we have that discussion. Awesome. So let's go warm up. Go. On your whiteboards. Number 1, do not yell it out. Good. Number 2. Ooh, look at that. Number 3. And number 4. How nice. Right? I spend 5 minutes on cumulative review every day. I know that I need these second graders. This was done in what month? This was in March. Good. So we're well into second grade, and I've got a lot of stuff to review. And I want to know that I'm going to send these kids to third grade, and that they do know that 6 plus 9 is. So we don't have to spend a whole lot of time on this. Good. 15, 15, 15. I mark. Get set. Boys and girls, yell it out. What is 6 plus 9? 15. Every one of your whiteboards says 15. So nice. Julie, right? No, Janet, yes. Janet, how'd you get 15?
I took 1 from the 6, maybe 9, 10,
Who did it Julie's way? But I know I can always steal one, right? And so my brain just sits there and sees. And that's all they have to do. Who did it differently? How'd you do it?
I do 10 plus 6 is 16 and take 1 away.
Look at that, all right? One person compensates, another one sits there and says, hey, I just know it. You lower the 9. It's 10. It's like John's strategy before of adding it on, right? And then adjusting it in some way. Who did it differently? Oh, come on. How'd you do it? Yell it out, sir.
Straight to the fact.
There you go. And I accept that because there's always some kid, and all of a sudden I hit his glitch. Because you know what, gang? We lie. We lie to ourselves and we lie to our kids. We make them think that there's some magical formula for memorizing all the facts when every single solitary one of you has a glitch. I have 800s on every one of those SATs and GREs and all that stuff. I know more math than I ever need to know and never will ever use. And when I walk down to the airport this afternoon and I've got to buy something that's 80 cents and something that's 90 cents, you'd think that when I practice 8 plus 9 all the time, I write about 8 plus 9, I use 8 plus 9 all the time, my brain is incapable of saying 17. That's my glitch. My brain does 8 and 8 and 1. I do the double plus 1. Now, stop and think about that. Ready? 7 times 8. Yell it out. Watch this. Raise your hand if your brain just went, oh, 7, 8, 5, 6, 7, 8, right? 56. Come on, raise them tall. Look at that. Look around the room, gang. I've got another 10%. I've got 10% of the people in this room that need to kiss the floor upon which a 5th grade teacher walks. Right? You recognize that for your entire life you sit there and your strategy for that fact is not, I know it, I memorize it. You're never able to memorize it because you had the flu the week that we did 7 times 8. And so you have a strategy, you have a crutch, a wonderful crutch that says 5, 6, 7, 8, 56. 8 times 7, 5, 6, 7, 8, 56. Ready? 7 times 6. I know it's 42. Now, convince me it's 42. Oh, there's dead silence in the room, but well, there should be. And so you ask that question. Well, Steve said to ask the question, convince me. You gotta say, turn and tell your partner, convince you that. I'm gonna cut right through this. I'm gonna remind you that if we're going to teach kids facts, it's about strategies. It's about fluency based upon conceptual understanding. You know, or you need to know, that for every kid that sits there and knows, oh, it's 46 and we feel like we're such great teachers, there's another kid saying, I hate that fact. And you know that that's why 6 times 7, look at that picture. How many of you to this day, 6 times 7, your brain says 3 7s is 21. 21 and 21 is 42. That's right. Amazing, amazing. You're sitting going, I never would have thought of that. Well, that's because you haven't asked kids how they think about it. That's because you haven't recognized that there are many different ways to do it. We're differentiating right now. We're giving kids access to it. I hate 7 times 6. I love 7 times 5 because the 5s are so cool. 7 times 5, how much? 35, everyone knows that. Plus, I see this picture, plus another 7. 6 times 6, I love 6 times 6. That's this picture. That's the 6 6s. And one more 6. Who's right? All right, so notice how I do the cumulative review, but I use it not just as answers, but as a chance. How did you know that 35 and 10 is 45? I need kids to say, well, that was so obvious, I counted on. Another kid sits there and says, well, if you got 10 more, you change that 10 digit from a 3 to a 4. Oh my goodness. Does everyone understand that? Saisha, can you repeat that? Oh, cool. All right, nice. Ready? Cool. So now let's start that. Good. Boys and girls? Oh. Tell me about Pablo. Yeah, so I'm sitting on the road with the kids, and obviously we're in Nito. Pablo has 46 cards. Nicole has 34. Look at that. So I'm taking exactly the same thing, and we're building it out in the lesson. I take from my materials, I take from Engage New York, I take from other places, and I start one by one. Right? Pablo, tell me about Pablo. Good. Tell me about Nicole. Good. What's the question? There it is. What do you notice? What's the question? What do you wonder? And all that stuff plays out, but look at how I have my slides animated to be able to do this. Right? What do you wonder? My favorite 2 questions, other than why. Good. I wonder how many they have altogether. Why would I take that data and limit it to how many more cards does Pablo have than Nicole? When I can sit there and go, how many have altogether? How many would they have if they shared them? How many more does Pablo have than the game? Good. Convince me that Pablo has 13 cards, and there it is, gang. There's the magical question. That's the question where I give them the answer and make them justify it and convince us. And so I'm increasingly convinced that the best way that I know to help people implement these 8 mathematical practices is to absorb them, is to understand them, is to use this amazing book as book study, as to use the 6 pages for each of the 8 things in every other week, because you can't absorb more than 2 a month. So every other week, we read the 6 pages, we discuss them, we go try them out in our class, we come back and we talk about them, we create some videos of what happened when it worked and what happened when it didn't work. We come together as colleagues, and then we try some lessons out, and we build in these animated slides to be able to do that. All right, so there we go. We've done all that stuff. Good. What do you notice? And now we're off to the ranches. Now we're off to the races. That's right, not the ranches. We're off to the races. The bake sale. What do you notice? Look at that data. In other words, what I'm doing is I'm saying every one of you knows that you're finally going to get to the set of data, the table, the chart, and ask kids 5 questions because it's in the Extra for Experts. It's in the C problems. It's the application section at the end. Why don't you start there? You know in this room there are outliers. There are people who have always said, why don't I start with the end? You've been to Grant Wiggin stuff and you know about backwards mapping and you apply it one additional step and you realize, start from the back. Go to Engage New York, it's free. You've got colleagues who will go find it and they put it on a slide, they email you the slide, and then you sit there and go, so the question is, what do I do with that data? On your mark, get set. Do not look. Don't. It's all three right there, okay? The next bunch of slides have all these questions. Don't look. Ready? You have 2nd graders. You have 3rd graders, you bump it up. You have 4th graders, I got a menu with a recipe with fractions in it. Ready? At your tables, 4 questions that you could ask kids. Go. So, what can I ask? This is why it cannot be done by ourselves. We've got to come together with this. This is what a faculty meeting is about. This is what a grade level meeting is about. This is what a professional learning, that's what it's about. Community, because we're all in this together. What are you gonna do? Ask the kids, Dustin?
How much money, or what could I buy with $100?
Oh my goodness, what can you do with $100 or 100 pesos? And they're sitting there going, he stole our question. Exactly right, good. You got another one?
Yes, how much would I need if I wanted to buy muffins and brownies?
Ooh, look at that, muffins and brownies, man.
How many cookies could I buy? 600 pieces.
Oh my goodness, look at that, and you got kids. You understand kids are doing this. You understand that kids come up with this. You understand that, in fact, this is early on. Before I ask the kids all these questions, which I could do, right, you've got this. Okay, so order the prices from least to greatest. That's not the objective. Well, no, I'm doing cumulative review. What good is it if I can't order these numbers? And so my questions are what determines the quality of their learning, and you all know that. My questions are key. And I can't be trusted to read them. I can't be trusted to remember them. So I put them out here and I leave it up there for kids. By the way, I got 4 kids that are absent. What do? I send the slides home. I tell the parents, go teach your kid the lesson by reading it and having your kid do the work. Oh my goodness. You can do that? Of course you can do that. I don't own these slides. You don't own them, okay? Go find them. Gee, what would be worse than kids cheating and looking at the slides? Right? Thank you. Okay, you want to learn? I was sitting with the 6 brightest kids in the multivariate calculus class of the Shanghai American. There is a sophomore who has already aced all of his AP exams. A sophomore, and he is in multivariate calculus. He's off the charts, right? One of the kids is off to MIT, another one's going to Williams because he decided Harvard wasn't good enough for him, right? I mean, really amazing, amazing kids. And so I sit there and I say to the 6 of them, 5 boys, 1 girl, I go, I don't understand all this stuff. Where did you, you know what they all said? On the internet. I said, where on the internet? He says, well, we started with Khan Academy, right, but that became too easy. So now we go to other websites, and we learn, we sit there. I said, how often? He says, oh, I spend 2 hours a day probably looking at problems on the internet and all. And so, I mean, look at what we've got here in terms of the possibilities, right? Order the prices, good. How much more money does the most expensive item cost than the least expensive? Right? So most and least and things like that, right? And all I can tell you is that this lesson worked beautifully. All I can tell you is that in March, these were the appropriate questions, that every one of these had the kids on their whiteboards. Remember, the kids all had their base 10 blocks. And so it was really wonderful to see who was able to model it, and we talked about how did you do it, how did you do it, what picture did you use, what representation. It was amazing to see the fact that we were in a class where this teacher regularly used both the bar model and the who's it call it thing, you know, this guy. What do you call it? Thank you, the number bond, exactly. And we had this guy, right, sitting there, right? Part, whole, part, whole, right? So, let's see. Find the two items with a difference of 29. That's not the one I want to do, right? We'll come back to that because it's right there. How much more money is the most expensive than the least expensive? So now I'm talking about, wait a second, I got the two parts. How much are they apart, right? What's the difference between the two of them? So I've got, talk to me. 60. Right? 20, oh wait, 60, now that's the total there, that's 27. Oh, this is not so easy. That model doesn't work so well for that particular problem. Now wait a second, a number line would work a whole lot better, right? What's the difference between the 60 and the 27? Oh, so what's the most amount? What's the total? What's the thing going on here? How do I see that this is the 60? It's not easy to talk about representations. But we find different ways of playing with that stuff out. We've got our questions. We sat there and did all, whoops, this goes back this way, right? Make up your own problem. There it is. Now go trade with a partner. So nice. The kids are doing all the work. The kids are solving each other's problems. The kids are checking their work in that kind of way. Good. Who wants to share a cool problem that they wrote or they heard? There we go. I had this cool problem. I made it up. I'm so cool, right? No, I don't. My partner had a great problem, right? Good. Your turn. Make up a problem that would require you to find the difference of 58 and 27. Solve and explain. End of story. Great. Boys and girls, what did you learn today? Good. Let's see if you learned it. Go. What's the difference? Show two different strategies that you can use. Ladies and gentlemen, there is nothing there that I think is not accessible to all of us. There's nothing there that requires anything other than honoring the idea of a clarity of goal, a task or a set of tasks, in this case the major task, sitting there with that data. Asking a couple of questions that are key, giving kids time to play, focusing on alternative approaches. How do you know? How do you know? Use your number bond, number cubes, and all that stuff to go do it, right? And then go make up your own problem, and we're all set. And the other thing that that tells you, right, is that I can't do it in less than an hour a day. I used to say, well, it's not the end of the world if you only have 50 minutes. Doesn't happen. When you actually teach these lessons, as I've been doing nonstop for 2 years all over the world, when I have 50 minutes, the lesson gets compromised. I start to rush. I start to cut kids off. I start to push. I start to tell. When I have an hour, it works. I can do my cube review, I got time for my exit ticket, and I got time for kids to be actively engaged in what's going on. All right? And so your turn. All right? This appears to be, so you have all the slides right there, right? Your exit ticket to get out of this room for your break is the discussion we have that emerges from your table discussions right now. I need you to capture. This appears to be an effective lesson because, think about it in terms of the goals, the tasks, the representation, the discourse. Here's what I might do differently. What made it effective? Articulate that. Articulate it from the perspective of, oh, I'm already doing it. Articulate it from the perspective of, I should be doing more of it. Articulate it from the perspective of, yeah, but I would add this, I would change this. Raise your hand if you do not know what I want you to do for the next 5 minutes. Go. Sorry, hello, you're looking up there. What do you see? Oh, I love it. This class is so wonderfully mathematically strong. And if that's a triangle, what's that? Oh, this is so great. You are watching god-awful instruction. You know that what I'm doing is ignoring everything we know about enriching things beyond depth of knowledge level 1. I am here to remind you that if all we do is mathematics based upon identification, naming the shape, we are missing out on all the reasons why mathematics is so amazing. And so I want you to see, one more time, it is our questions that determine their learning. And again, these questions are generic. So instead of this, I say to you, are you ready? Turn to tell your partner 5 things you see. I got my third graders, and I see their whiteboards. Awesome. Boys and girls, so here's what I see in this class. It's really cool. I see a blue figure. I see a polygon, right? I see a triangle. I see a scalene triangle. No, I see a right triangle. I think it might be a right triangle. No, it's an obtuse triangle. I see three angles. I see three sides. I see three vertices. Oh, interesting, right? I see a ramp. I see Virginia rotated 180 degrees. I see a mountain. Go ahead, gang, make us day. Make our day. What else did you see that should be on my list? Come on, we got it. Tell us.
Oh, there's no line.
Look at that. Say it louder.
No line of
Tree. Oh, that's so awesome, right? So I immediately put that down. What, it's in my curriculum? Why would I not do that? There is no line of symmetry. I am sending the message that is about thinking and reasoning. I am sending the message that your opinions and your contributions are valid and validated. And so, what's the next thing on my slide? Once we have identify those things and I write them down, look at what happens when I move so far beyond just, it is a triangle, it is a square. And I sit there and say to kids, convince me it's a polygon. Whoa, I don't know what a polygon is, right? I say, Jennifer, go to the computer and look it up, right? Come on, gang, we live in a world where the answers to all those questions sit on your iPhones, they sit on their smartphones, they sit on a computer. I want kids to recognize, I go and find out what a polygon is, a shape with some number of sides, right? There are sides. Convince me there are three sides. You know what happens, right? Jennifer comes up to the board. There's that blue triangle sitting on the interactive whiteboard, and Jennifer says, three sides. 1, 2, 3. And I go, awesome. Jennifer, it looks to me like that was a point, that was a point, that was a point on the sides. Oh, this is a side, this is a side, this is a side. Neat. Somebody said there were three vertices. I don't understand. Where are they? Oh, those are the points. You think this is easy? You think this idea of vertices are the points and the sides are the line segments? Oh, how interesting. And yet I thought there were three angles. What happened to the vertex? Well, there's the vertex, and now those are rays. There's an angle formed with two rays with a common endpoint. A line segment. That's not easy. That's confusing. But that's something I want to have to that's really interesting, right? But that's what's going on. Two rays that meet end up forming a line segment in the way that plays out. They have endpoints and except they go on forever, except you have to. Are you clear? We have this whole discussion. Good. On your whiteboards, boys and girls. What's a triangle? Why? Why would we tell kids to open to page 274 and read the obituary column? The black box surrounding a triangle is. When the question is, what's a triangle? Will you tell me, no, gang, we figure this stuff out. Right, that's what we do. Now you're sitting there going, I have no idea. I don't care that you're sitting there saying I have no idea. You see, I'm warped. I spent from age 15 to age 18, age 15 to age 18, teaching kids to water ski on a beautiful lake in Sweden, Maine, before I ever water skied myself. Oh. Who are the best musical teachers? The ones that can't play the instrument as well as the people they're coaching. You think that the great coaches in Iowa, in your high schools and in your colleges and in this country can play as well as their players? That's absurd. Okay? You do not have to know all the answers to be an incredibly powerful teacher. You need to be curious. You need to be encouraging. You need to be empowering. And so you sit there and you watch kids wrestle with, right? Well, a triangle is this. A triangle is a figure with three sides. I sit there and go, awesome, right? Neat. So I go, side 1, side 2, side 3. No, that ain't no triangle. Well, why not? Good. How can we help them? It's a triangle is a figure with three sides that have three common endpoints. Whoa, look at that. Kid says, no, a triangle is a polygon with three sides. What's wrong with that definition? Yeah, that's right. On the one hand, nothing is right. On the other hand, it's horrible. Oh, neat. Good. So, right, let's see what Wikipedia says. We have those resources, and so I'm here to tell you that this issue of computer literacy, this issue of, we live in a world where Tom Friedman and Bill Gates says that the issue is, how do you use all the information that we have access to, as opposed to pumping your brain full of stuff that nobody needs to remember and know, because it's all about going to find it and then knowing what it is. And so you go to Wikipedia and Google with your third graders, and What is a triangle? Let's see how close we came. A plane figure with 3 straight sides and 3 angles. Doesn't say closed. Not exactly very good. And then Wikipedia says an equilateral triangle. They take the special case as if that is the triangle when we know that they go far beyond that. By the way, notice I haven't talked about scalene. I haven't held up my corner of my paper to see if in fact back there it is a right angle. It looks like a right angle. Maybe it is. Maybe it isn't. Maybe it's 92 degrees, which is what it actually is, because it's an obtuse triangle. Oh, neat. And then along comes Google. You gotta love Google. A thing shaped like a triangle. Like a small triangle of grass. You should be rolling, you should be laughing. You can't define something with what it is. It doesn't help you in any which way, right? And then you know why this is so hard and why this is so important. Because inevitably when you go to Google, it's not protected. And when you